Hello everyone, in this video, I will give a tutorial how to plot data in the OriginLab on XRD, UV-DRS, SEM, and also FTIR characterization.
First, we have to copy the Excel data of nickel and copper and paste on the OriginLab in the column A and column B. And we have to name it in the units. In A column, we can name 2 theta, and then in the B intensity. And then we copy the GCPDS peak of nickel and then paste on the OriginLab in the next column, but we just need last of 2 column and then copy, but before that we have to delete it the C until the end and then paste on the C and D, and we also have to name it GCPDS nickel and then 2 theta, and in the D is intensity. And then we copy in the peak of cuprum or GCPDF cuprum, and then we also do the same. We just need the last of 2 column. We copy, and before we have to delete it the E column until the end, and we paste on the E and F column, and we also name it GCPDS cuprum and GCPDF cuprum and 2 theta and intensity. And yeah, we got like that. And then we set the C column set as X, and we also do the same in the E column. We set as to the X variable, and then we have to plot all the data. Click multi-panel, multi-axis, and then we choose stacked panels and click preview, and we got like that, and OK. And we have to click the graph, and we change in the line, in the connect to no line, and then drop lines, and we click vertical and OK. And we do the same in the line, in the connect, we change to no line and drop line. We checklist the vertical and click OK. Next, we click the box of graph and we click analyze, and then signal processing, smooth, and open dialog, and we click preview, and we got like that, and we have to change the point of window to be 30 and OK. And we click the graph, and we uncheck list on the booksheet 1, and then click OK. Yeah, we got the red graphs, and we have to change the scale according what we want. And also in the vertical, we have to change in order to get the sharp of graph, and we got like that. And we change the name of variable. Yeah. And we click analyze, pick and baseline, pick analyzer, open dialog, and we get like that. And we have to make sure that the call is integrate peaks, and we click next, next, next until find peaks, and we uncheck list, and we click add, and we have to choose the peak but that way we want, and I choose 5 peaks. If you're done, you can click done, and then we change the direction to be a positive, and we can click next. Now we get like this, and we have to shift right and left in pick that we choose, and then finish. And you can click Project Explore and then choose the book. Now we get like that. In the center data, we can copy and we can move to the Excel. In a peak position, and we got the average of size of crystal. And in the FWHM, we copy also, and the final, we got the size of crystal. And to the area, we have to copy and paste in the Excel, and we got like that. And in the surface area, we click the grabs and click box of grabs and analyze, pick and base plan, pick analyzer, open dialog, and then we get like that. Next, and then we uncheck list and then click add, and we do the same like before. We choose the peaks, click down, and then we change the direction to be a positive, click next, and then we search on edges on preview grabs, and we uncheck list all peaks, and we change 5 to be 1. Click OK, and then we have to shift right and left to the all of area, and we got the area is like that. And then we move to the Excel, and we got the crystallinity like that. And we have to save the project. Click save and then save project and place in the folder that you want and name it. Okay, done. Okay, to the second data, we copy the data of nickel, copper, and zinc from the Excel, and we paste in the OriginLab. And we have to name it in the long name as a nickel, copper, and zinc. And in the unit, in the column A, we name it as 2 theta, and in the B column is intensity. And then we move to the GCPDS of peak of nickel. We copy the data, and then we paste on a OriginLab in the column C. But we just need the last of 2 columns. We copy, and before that we have to delete, and then paste on this column C and D, and we got like that. And we also name GCPDS of nickel, and then in the D column as also, and then in the units to theta and intensity. And we move to the Excel data of GCPDS of cuprum. We copy the data and then paste on the OriginLab. And like before, we just need last of 2 column. So we have to copy the last of 2 column and then paste on the column E and F. And then we also name it GCPDS of cuprum and then GCPDF of cuprum. And then in the unit, like before, to theta and intensity. Next, we move to the GCPDF of zinc. We copy the data and then paste on the OriginLab. And like before, we just need last of 2 column and then we copy and paste on the column G and H. And we also name it GCPDS of zinc in the G column, and then in the H column GCPDS of zinc. And in the units, like before, to theta and intensity. And then we set the C column set as X variable. In the E column, we set as X variable also. And then in the G also set X variable. And then we have to plot all of the data. We click plot. And then we choose multi-panel, multi-axis, and then we choose stacked panels. And we got like that. We click preview and OK. And we got the graphs. And then we click the graphs. You have to zoom. We click the graphs. And then we change the connect straight to the no line and then drop lines. We checklist the vertical and click OK. And we do the same to the next graph, no line, and then we checklist vertical line and click OK. We click, we change the line connect straight to be no line, drop lines, and checklist the vertical line and click OK. And then we click the box. And then we click analyze, signal processing, smooth, open dialog. And then we click preview. We got like that. And we have to change the points of window to be a 30. And we got like that. And we click the graphs. And we unchecklist book sheet 1 in the up. And then we click OK. And we got like that. And then I want to change the scale of variable. We can change like what we want to get the sharp of graphs. and I want to change the name of variable. Then we click the box and analyze, pick and paste line, pick analyzer, and then open dialog. And we got like that. And then we can click next, and next, until find pics, and we uncheck list in the enable auto find, and then click add, and then we choose the pic that what we want to analyze. In this data, I will choose 8 pics. If you're done, you can click done. And we have to change the direction to be a positive, and next, and we have to shift right and left in the pics that we have choose. If you're done, you can click finish. You can be like that, and then you have to click Project Explorer and then click Book 1, and you get the center. You have to copy to the Excel in the pics position and paste. And then in the FWHM, you have to copy also and then move to the Excel. Then paste to the Excel, and we got the size of crystal is 6.091. And in the surface area, we have to click the area column and then copy to the Excel, paste, and then in the surface of area overall, we have to click Project Explorer, the grab, and then we click the box and analyze, pick line, and pick analyzing, and open dialog. And we have to click next, and then we uncheck list, enable auto find, and then click add. And like before, we have to choose the pic that we have choose before, 9 pics, and then click done, and then change the direction to be a positive and click next. And then integration change to adjust on preview grab, and then uncheck list all pics and number change to be a 1 and click finish. And we can minimize this, click OK, and we have to shift right and left to the all of surface area. And we got in the bottom, we got the surface area, and then we have to move copy in the Excel. And yeah, we got the crystallinity and done. And then we have to save the project, save as project, and place in the folder that you want and name it. and then we have to save the grabs. Click Project Explorer, export grabs, and then open dialog. Okay, in this tutorial, I want to set C column, set as X. And then we have to move to the absorbance data in a Excel. And then we have to copy and paste to the OriginLab in a column A and B. Then we move to the %R data, and then also we have to copy and then paste to the OriginLab. And then we have to name it in the long name in the A column wavelength, and then in the B is absorbance, and in the C is HV, and then enter the equation of Fx, and then enter the equation for the column for the long name, and then enter the equation in Fx for the column. Then we plot C and D column. We can click plot and then line, and we got like that. And I want to set the scale to be 1.6, around that, so I get the graph like this. And then I want to change the name of variable horizontal with number. And then we click the line and making a line for the graph. And then we can point it in a horizontal line, and then we can screen reader the point that we have, and we got X point in the bottom, and give it name band gap. X is 3.8567, and then we can save this project, and then name it and place in the folder that you want, and we can click save. Okay, first we have to copy the absorbance in the Excel and paste to the OriginLab. And then I want to set the C column to set as X. And then we move to the Excel in the %R data Excel. And also we have to copy and paste to the OriginLab in the next column. and I want to name it. A is a wavelength, and then B as the absorbance, and then in the C is HV, in the D is equation like that. And in the Fx, in the D column, we have to enter in the equation. And also in the C column for Fx, we have to enter in the equation. And we got like that. And then we have to plot the C and D column, click plot, and then we choose line. And we got the graph like that. And then I want to set and change the scale from 1.6, and we can draw a line from the graph, and we can pull in the horizontal line, and we can screen reader, and then we got the X in the bottom. We can see the X that we got is 3.7629. We can name it band cap. And after that, I want to change the name of variable in the horizontal to be wave number. And then we can save, click file, and then save project as, and we can name it and place to the folder that we want. And then save. We have to open image G and then click file and click open. And we have to choose the picture of molecule that we want to analyze. Then we can click analyze, set scale, and we have to change the distance in pixel to be a 0, non-distance to be a 0, unit of length to be pixel, and click OK. Then we can draw a line in the scale. If you're done, you can click analyze, then set scale. Then we have to change no distance to be 1000, and then unit of length to be a nanometer. Then click OK. Then we have to draw at least 3 sites of molecule that we want to analyze. In all around of area. Then we can click analyze, measure, and we got like that. or you can use a shortcut with Ctrl D plus M, so that we have to get around above of 50 data, and then we have to copy, then move to the OriginLab and paste on that. And in the column B, we can plot and choose histogram. And we got like that. And this histogram we can click. Then we have to choose go to bin worksheet. And we got the data like that. And then we click AB to plot that. And we choose column. Then we can click analyze fitting, nonlinear curve fit, and open dialog. And we have to change the category to pick function. And then the function we have to change Gaussian. Then in the advanced, we have to search fit statistic. We can click this and we search R value. We have to checklist the R value and click fit. Then click OK. In this data that we have, we can see that the R square is 0.99, and then we can click the project explorer to be a grep 2. We can see that the R square or the error that we get, and then the equation to be like that, and we can save as project and name it, and also we can place in the folder that we want. We can move to the Excel data of titanium and manganese. Then we can copy, then paste to the OriginLab. Then the A is wave number. Then for the B column is the percent transmittance. Then we can plot the A and B column and we can choose line. Then we have to reverse the scale from big to a small. We can click scale, then from around 4,000 and to 500. And then click OK. And we got like that. And then we can screen reader on the valley. And we can see the X number that we got. Then give it the text. Then we can rotate. And we also do the same for another valley. We can screen reader. Then also we have to give it the text, the number of X. And we can save this project, name it, and place in the folder that we want. And we can click save. And we can save the grep with click export graph and then open dialog, also name it and click OK. So we have to copy the data from the Excel, be on column A and column B, and then we name it with number for the A column, and for the B column is percent transmittance. Then we have to plot, click plot, and then we choose line, and then we got like this. Then I want to set the scale from big to small, from 4,000 to 500, and then click OK. Then in the percent transmittance, I also want to change the scale to get the sharper of a valley or peaks. Then click OK. So we got like that, and then we can screen reader the valley that we got, and then we have to name it. We have to give a number according by the point of X that we got. Then we can rotate and do the same for another valley. So we can save the project and name the project and place in the folder that we want. Then we can save export the graph and click OK. We can name the A column as a wave number and then B column as a percent transmittance, and we set the C column set as X. Then we copy the name to get same name for C column and D column. Then we move to the Excel data. In the first data, we have to copy the first data into the OriginLab. Then we move to the second data. We also have to copy, then paste to the OriginLab in the C and D column. And we have to plot the all data, and we click line, and we got like this. And I want to change the scale. We have to reverse from big scale into to small scale, 4,000 to 500. Then in a vertical also, I want to get a sharp valley or peaks. So we got the graph like this, and I want to check where is the first data and where is the second data. So we got the in the black line, that is a first data, and then in the second data is a red line. And we can screen reader the value that we got and then give the text the X point that we got. Then we do the same for another value. Then we can save the project, click File, then click Save as Project. Then we have to name it and place in a folder that we want and click Save. Then we also have to save the graph, name it and click OK, or you can place in the folder that you want.